Hello students, I am Subhashish. In our previous session, we have learnt about factorization of polynomials by splitting method and by factor theorem. Let us recall the factor theorem. Factor theorem. If p of x is a polynomial of degree n greater than 1 and a is any real number, then x minus a is a factor of p of x if p of a is equal to 0 and p of a is equal to 0 if x minus a is a factor of p of x. Learning outcomes. By the end of this lesson, you will be able to understand and apply algebraic identities for expanding and factoring polynomial expressions. Solve problems involving polynomial products and factorizing using algebraic identities. Extend algebraic identities to cubic expressions and apply them to factorize cubic polynomials. Use algebraic identities to simplify calculations and factorize complex expressions. Keywords from this session are algebraic identities, polynomial expressions, factorization, factor theorem, expansion, cubic polynomials, simplification. In our previous classes, we have learned some algebraic identities. Let us recall the identities. Identity 1. X plus y whole square is equal to x square plus 2xy plus y square. Identity 2. X minus y whole square is equal to x square minus 2xy plus y square. Identity 3. X square minus y square is equal to x minus y into x plus y. Identity 4. X plus a into x plus b is equal to x square plus a plus b into x plus ab. In our previous session, we have seen examples on factorizing by factor or splitting method for the algebraic expressions. Now we will use the identities. Let us see some examples. In the product of given polynomial x plus 5 into x plus 5. Solution. Given x plus 5 into x plus 5. This polynomial product can be obtained by using the identity x plus y whole square is equal to x square plus 2xy plus y square. X plus 5 into x plus 5 is equal to x plus 5 whole square. Which is equal to x square plus 2 into x into 5 plus 5 square. Which is equal to x square plus 10x plus 25. We have seen the uses of identities in finding the product of some given expressions. We can also use these identities in factorization of algebraic expressions. Let us see some examples. Factorize the following polynomial using identities x square by 16 minus 4y square by 49. Solution. Given x square by 16 minus 4y square by 49. In the equation, 16 can be written as 4 square and 49 can be written as 7 square. Then the equation can be written as x by 4 whole square minus 2y by 7 whole square. Here we can use the identity a square minus b square, which is equal to a plus b into a minus b. X square by 16 minus 4y square by 49 is equal to x by 4 whole square minus 2y by 7 whole square, which is equal to x by 4 minus 2y by 7 into x by 4 plus 2y by 7. Let us generalize the identity x plus y whole square and define identity x plus y plus z whole square. Write the binomial identity x plus y whole square is equal to x square plus y square plus 2xy. Now consider x plus y plus z whole square. Let y plus z is equal to t. X plus t whole square is equal to x square plus 2xt plus t square. Since identity x plus y whole square is equal to x square plus y square plus 2xy. Here replace t with y plus z. Then we get x square plus 2x into y plus z whole square. Since y plus z is equal to t, we get x square plus 2xy plus 2xz plus y square plus z square plus 2 into yz, since by using identity x plus y whole square. By rearranging the terms, we get x square plus y square plus z square plus 2xy plus 2xz plus 2yz. So the identity is defined as x plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2xz. Let us see one example. Expand p plus 2s plus 5r whole square. Solution. Given p plus 2s plus 5r whole square. Let us compare the given expression with the identity x plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2xz. Then x equal to p, y equal to 2s and z equal to 5r. Where p plus 2s plus 5r whole square is equal to p square plus 2s whole square plus 5r whole square plus 2p into 2s plus 2 into 2s into 5r plus 2 into 5r into p. After solving, we get p square plus 4s square plus 25r square plus 4ps plus 20sr plus 10rp. We have seen the identity of degree 2. Now we will see the identities for degree 3. Now let us extend the identity x plus y whole square to compute x plus y whole cube. We have x plus y whole cube is equal to x plus y into x plus y whole square. By expanding, we get x plus y into x square plus 2xy plus y square, which is equal to x into x square plus 2xy plus y square plus y into x square plus 2xy plus y square. After solving, we get x cube plus 2x square y plus xy square plus x square y plus 2xy square plus y cube. After adding the terms, we get x cube plus 3x square y plus 3xy square plus y cube. Similarly, in identity x plus y whole cube, by replacing minus y, we get x minus y whole cube is equal to x cube minus y cube minus 3xy into x minus y. X minus y whole cube is equal to x cube minus 3x square y plus 3xy square minus y cube. Example: write the expanded form for the cubes given below 2a plus 5b whole cube. Solution: given 2a plus 5b whole cube. Comparing the given expression with identity x plus y whole cube is equal to x cube plus 3x square y plus 3xy square plus y cube, we get x equal to 2a and y equal to 5b. Then substitute the x and y value in the identity, we get 2a plus 5b whole cube is equal to 2a cube plus 3 into 2a square into 5b plus 3 into 2a plus 5b square plus 5b whole cube. After solving, we get 2a whole cube plus 3 into 4a square into 5b plus 3 into 2a plus 25b square plus 5b whole cube. Then after we get 8a cube plus 60a square b plus 150ab square plus 125b cube. Let us see one more example. Write the expanded form for the cubes given below. 7m minus 3n whole cube. Solution: given 7m minus 3n whole cube. Comparing the given expression with identity x minus y whole cube is equal to x cube minus 3x square y plus 3xy square minus y cube, we get x equal to 7m and y equal to minus 3n. Then substitute the x and y value in the identity 7m minus 3n whole cube, which is equal to 7m whole cube minus 3 into 7m square minus 3n plus 3 into 7m into minus 3n whole square plus 3 into minus of 3n whole cube. After solving, we get 373m cube plus 441m square n plus 189mn square minus 27n cube. Let us see one more identity. X plus y plus z into x square plus y square plus z square minus xy minus yz minus xz is equal to x cube plus y cube plus z cube minus 3xyz. Let us solve a problem by using this identity. Example: factorize 64x cube plus 27y cube plus z cube minus 36xyz. Solution: given expression is 64x cube plus 27y cube plus z cube minus 36xyz. Then 64x cube plus 27y cube plus z cube minus 36xyz is equal to 4x whole cube plus 3y whole cube plus z cube minus 3 into 4x into 3y into z. From above, we get x equal to 4x, y equal to 3y and z equal to z. Therefore, we can write it as 4x plus 3y plus z into 16x square plus 9y square plus z square minus 12 into xy minus 3 into yz minus 4 into xz. Points to remember. Identity 1. X plus y whole square is equal to x square plus 2xy plus y square. Identity 2. X minus y whole square is equal to x square minus 2xy plus y square. Identity 3. X square minus y square is equal to x minus y into x plus y. Identity 4. X plus a into x plus b is equal to x square plus a plus b into x plus ab. Identity 5. X plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Identity 6. X plus y whole cube is equal to x cube plus 3x square y plus 3xy square plus y cube. Identity 7. X minus y whole cube is equal to x cube minus 3x square y plus 3xy square minus y cube. Identity 8. X plus y plus z into x square plus y square plus z square minus xy minus yz minus xz is equal to x cube plus y cube plus z cube minus 3xyz. Thanks for watching.